Welcome to Stats Unit 1 Lesson 3, Measures of Variation Using Quartiles and the IQR. So last lesson we looked at finding outliers and typical or expected ranges of values using the mean and the standard deviation. Remember, anything that is more than 3 standard deviations away from the mean is an outlier. But of course the mean is only good for symmetric datasets that do not have outliers. If we do have outliers, the interquartile range is going to be better. So, example 1. How many pairs of shoes does a typical teenage boy own? To find out, 2 stats students surveyed a random sample of 20 boys from their school and recorded the number of pairs of shoes each boy owned. Here are the results. Numbers of shoes. We need to find the 5-number summary. That's the minimum first quartile, median third quartile, and maximum. Third quartile is actually Q3. Then we need to calculate the IQR to find the most expected range of values for anything that has no outliers in it. Your most expected, most typical values are going to be between 1 standard deviation above the mean to 1 standard deviation below the mean. But here it's going to be between your 2 first and third quartiles. And then use the IQR rule to identify any outliers. So first thing we need to do is we need to put all of these numbers in order from least to greatest, and to save us a little bit of time in the video, I have pre-done that. So putting in from least to greatest, I can see that my minimum value, my smallest number of pairs of shoes recorded, was 4. Q1 we'll get in a moment. Our median we'll get in a moment. Q3 we'll get in a moment. But our maximum, our biggest number, was 38. That is relatively easy to see. So again, our median is going to be the middlemost number. So if I just check off first and last, until work my way into the center of this list, this is the by hand method. We'll show you how to do this by calculator in a moment. So it's going to be somewhere between 8 and 10. So our median, 8 plus 10 over 2, comes out to be 9. Again, the median is in the middle of the data set. And the middle actually comes between that 8 and that 10. Now the quartiles are the medians of each half, the median of the upper half and the median of the lower half. So remember, if you cut a half into a half, it becomes a quartile, or a quarter. So we are still using the 8 and the 10 as we work our way towards the middle of the first half. So Q1 is going to be halfway between 6 and 7, or 6.5. And then Q3, again, doing the same thing, working from end to end, or working from the ends toward the middle. Q3 is going to be halfway between 11 and 12, or 11.5. So that's our 5-number summary. Now we can use the IQR to find the most typical expected range of values. So the typical is between 6.5 to 11.5, and the IQR, the range of that, is always the Q3 number, the bigger number, minus the Q1 number, the smaller number. So 11.5 minus 6.5, the biggest range between between numbers of shoes that we expect most of these teenage boys to have will range by about 5. Typically, we expect them to have about 9, plus 5 or minus 5. But again, most of them, sorry, not plus 5 or minus 5, typically about 9, but, you know, down to 6.5 and up to 11.5. Now, the IQR rule tells you what outliers are. The IQR is just the interquartile range, just this range of 5. But the rule says high outliers will be greater than 1.5 times let me check my note for a moment. High outliers are bigger than quartile 3 plus 1.5 times your IQR. So anything that is a high outlier is going to be bigger than 11.5 plus 1.5 times 5, or any high outliers are going to be bigger than 19. Anything over 19 is an outlier, and looking through our list, that means that 22, 35, and 38 are high outliers. But that's only half of the IQR rule. We also have to check for low outliers. Low outliers are going to be less than Q1 minus 1.5 times your IQR. So again, our low outliers are going to be numbers that are smaller than 6.5 minus 1.5 times 5. Or anything lower than -1 pairs of shoes is a low outlier. Can't really have -1 pairs of shoes here, so there are no low outliers. And that was example 1.